then they want to wonder how to make the country work. So I went and said, can I have something to clean the blackboard? I said, oh, we don't have it. I said, you don't have it. 3 people, you don't have to spray, no. He says, oh, it's only the cleaning company. It's not us. You know, there was this thing. I went to the United States in '83 to study. And there was a number of surprises to adapt to the new life. And one interesting thing was, after a while that I was at the university, I realized something was missing at the university. Everything was working fine. Actually, everything was working perfectly. The university was open 24 hours a day, 7 days a week. There were places to eat, many restaurants, the computer worked. I had my little office, everything was fine.
In '83 already? Already in '83? I mean, it's called.
Yeah, in '83.
We are still
well, we had a student, I know. In '83, we had a student lab in the basement of Arc and Soul, which had a dozen, probably, terminals that we could use. And that's the year I learned about bitmap. That was the way mail was called. I made friends with people in the physics department, and they were connected to Fermi Lab and so on, and they were already in the ARPANET. And so they used bitmap, and so my first mail was sometime in October '83. They created an account with this long bitmap address, and we would exchange messages. We created, was a group of Italian and French, 2 years apart, and in different departments, mathematics, physics, and so on. We created a kind of Mediterranean math group for a few years. We would meet once a week at 9. One of the people would teach his mathematics to the other. It was very interesting. So we learned, Feynman diagram, things, strange things that I never used, but it was very useful to see mathematics from the chemist, the physicist, the mathematician, the economist, the biologist, and then we would go for beers at 11, drink until we had enough, and then go to bed once a week. And so the appointment for the beer math group was via mail, and so it's a little thing. Anyhow, everything was working fine, but around October I said something is missing in this university. There is something here missing. And I couldn't figure out what it was because everything worked fine. And then I saw it one day. Bidelli were missing. There were no bidelli. There's never met a bidello in my life. And everything works perfectly. And so suddenly I had an illumination. Bidellis are useless. They're pure Keynesian expenditure. Waste of money. It's amazing. They are good for nothing. And now that this will go online, perfect. I'll be ranked as l'ennemi du peuple. You see, they have the l'ami du peuple and l'ennemi du peuple. Yeah, they are a perfectly useless institution, like many we have in this country. Well, all right, so this is being bombarded by science. So let's go through this. So we want to ask ourselves, profits, capacity constraint, disembodiment of technological progress. Here's the brief argument. I'm going to illustrate very briefly in 1 hour and 10 minutes. And then if you want, you go on and read. But David and I ended up writing that thing mostly out of surprise. We had been friends for maybe 12 years, and we had been observing this absurdity of new growth theory developing and wondering what they were trying to do. So at the beginning, it was this thing you saw of increasing return and so on. And we thought, okay, that's past. And then it was this whole idea that in order to understand innovation and innovative activity and technological progress, you need to understand and in fact foster monopoly. It's interesting that since then, even the main proponents of that line have finally come around now, and they have a much more practical and nuanced position, as usual, very democratic Christian for Italy, middle of the road. Oh yeah, not too much monopoly, not too much competition. We need state regulations to do things fine. It's good. It took 20 years to figure that out, that maybe monopoly is not good. It's an accomplishment. On my part, I never quite understood why. And so we ended up writing this stuff. But our point of view was, frankly, that what we were writing was obvious. In the same way that the Solow model, the von Neumann thing, was an obvious solution to the unbounded growth problem, okay? it was equally obvious to us that economics had for a century a very good starting point. Not the final model, but a very good starting point to understand innovation, imitation, and growth under competition. And it was the standard Marshallian model of a competitive industry. And so the way you want to read some of the stuff we've wrote and others wrote is purely, hey, look, the Marshallian model of a competitive industry is flexible enough to explain what we observe, and in fact is flexible enough to point out the main thing that has not yet been accepted, and it's a matter, it's a quantitative matter, it's an empirical matter. There are markets in which innovation is extremely costly and so easily reproducible, and demand is so elastic that maybe some form of protection, subsidy, price may be useful. We'll get to that. But in general, most markets, most industries, most sectors work just well in a reasonably free entry setting with people competing each other and imitating each other. And the main reason from a theoretical point of view are these. Technologies are not disembodied. If there is one thing I think that is crucial, and it's crucially wrong in the way economists have been treating technological progress for more than 60 years, is to treat technological progress as disembodied. Technological progress is embodied. That's what makes it very costly and hard to imitate and reproduce. The reason why the advanced technologies of the Netherlands or California, of Scandinavian countries or Korea, South Korea are not used in Calabria or Mexico or in the middle of the Amazon forest is because that technology is embodied. It's not just a blueprint that you read and learn automatically. It's not an externality. It doesn't get transferred for magic. It takes a lot of learning, so it's embodied in humans that have brains that have been hammered with knowledge for 20 years to make them capable of using that technology. You don't learn how to use modern technology just because you take a 3-month course. Okay? You do become an innovator, a person capable of using frontier technology out of the blue, because they show you the lab. You have to go through a long period of training, both theoretical and practical, depending on which field, doctor, physicist, an engineer, whatever. You got to go through. You don't even become an economist that quickly, and it's kind of simpler than other. You got to learn your stuff. There's a lot of things to learn. It's embodied. If what you're doing is a decent course, when you will come out of here, you will be a very different object from when you came in. And it's not externality, as you notice. You're not getting it for free. If you don't read the paper, if you don't listen to the lecture, you don't go through the exercise, you learn nothing. Okay? And the technologies are also embodied in machines. Some machines have become cheaper to reproduce, but the big infrastructure are very costly. Modern technology are costly. Technology are always costly. They're all embodied. Okay? That's the first thing to understand. Once you understand that they're embodied, you understand that imitation is not immediate. It's very costly. Adoption is very costly. Catching up is very costly. It takes a lot of investment. Okay? So it's not true. It's just a silly approximation to play the game, oh, I freely imitate. Okay? That's the first thing. The second is that there is no such a thing as an industry where there are no capacity constraints. And certainly not in new industries. New industries, new product, new technology are characterized by capacity constraint. They're limited. The new guys that know how to do the things new are very few. The new surgeon, the new chemist, the new biologist. The machines that are able to perform certain tasks, the robots, are few and costly. And if you want to use them, you've got to make copies, and making copies cost. And so on. This is true for every way. Capacity constraint is what characterizes innovation. There is not such a thing as the unbounded supply of the new good. Think of the lines of people in front of stores when the new version of this and that comes out, right? Think at the waiting time on the product you care. And so on. I mean, it's you know, the time it takes for the new airplane to spread. Why is it they're not all using the super new version of the new Boeing or the new Airbus? Right? Well, because it's a very expensive technology that isn't bought it, and it takes fantasticillion to have it, and you're not just gonna replace, you know, hundreds of thousands of airplanes around the world with the new Airbus just because it's more efficient. It doesn't work that way. Well, you know, one thing is to take approximation sometime. If you talk about particular example, I don't know, the speed at which you may reproduce some song, okay? And one thing is to make this into a theory that explains GNP, pretending that you can replace, you know, commercial jets at zero cost just because you imitate. Okay, so the capacity constraint is crucial. And the profits, yes, profits come in many forms in economic environment, and it's important to try to understand the form. So before doing that, with the model, let me actually make you reflect, think about a typical argument. This is, David and I have a paper on this, that one of the many we never published, we really should. The paper elaborates actually a Cournot version of the innovation game. But the reason we wrote it is because he pointed out to me one day, he said, Michele, he says, you know, David is the game theorist, he said, have you ever thought about the story that says, well, you know, if there is Bertrand competition, innovators will not innovate because they know imitators will imitate, and because the imitators can imitate at a much lower fixed cost, they'll end up playing Bertrand competition, okay? And in Bertrand competition, innovators realize they make negative profits, and knowing that, they'll stay out and never innovate. I said, yeah, well, he said, I thought about that, and if you write that down as a game, it has actually the opposite prediction, which proves how absurd those assumptions are. And so we worked it out, and it's true. So we think of this very simple game, you can make it much more general. Here is the innovator. Right? He has to move first. She can innovate and spend minus F, the fixed cost, or not innovate, spend zero. Okay? If the innovator does not innovate, the game ends by assumption. Right? And so the payoff for the innovator is zero, and for the imitators is also zero. Right? Okay? Once the innovator has innovated, the imitator turns. Imitators can either imitate or not imitate. If they imitate, they spend much less than the innovator. They spend epsilon f, where epsilon is very small. Or even zero. Okay? In the extreme case. It's never zero, but you know. If they don't imitate, they spend zero. Okay? If the imitator imitates, then in this equilibrium, in this state of the world, both imitator and innovator can produce the full supply, and they play Bertrand. And so the innovator loses all the fixed cost, and the imitators get that, right? Both sales at price equal marginal cost, and therefore the fixed costs are not covered. Okay? If the imitator do not imitate, okay, then the innovator is alone, makes monopoly profits, and the imitator stay out and get zero. Okay? This is the simplest form of that game. You can make it more complicated, but the substance is there. Now, look at that game. That game has one subgame perfect equilibrium. Which one is it? If you want, you can write that game in a matrix form, right? Inno, imi, right? And the payoff are innove, yes, no, yes, no, right? Yes, yes. No. Well, no, yes doesn't exist, so it's okay. Okay? Yes, that's called the normal form. I never remember that language. Okay? You can look at it either way. What's the equilibrium? Here it looks subgame. Here it's just the Nash equilibrium. There it's the subgame perfect.
Innovate, non-imitate.
Right. Exactly the opposite of what's supposed to be proving. Right? Remember, right? That argument is supposed to prove that this is the equilibrium. Right? Not innovate, not imitate. Nothing happens. Instead, this is the equilibrium. In fact, if you think a moment, the prediction is completely absurd. I'm not saying that the prediction is correct. I want to use the argument to show that the model is completely crazy. And the argument is crazy. Because the prediction makes no sense. It says I should observe everywhere there are no patent protection or monopoly protection, I should observe one innovator coming in and being a natural monopolist everywhere. Well, that's clearly not true. Please.
But here is the point is that the imitator has a fixed cost to imitate. But if I think about the fixed cost made by an innovator as a research cost, and the other costs are just production, I can think it's zero in that case.
Doesn't change.
Okay. So in this case, I mean...
This is an equilibrium only out of spitefulness.
Okay.
Only if you want to piss that guy off, right?
Okay.
Sure. We can build a theory of economics history based on fact people just want to piss everybody else off. That's fine. It doesn't look like an interesting theory to me. And remember, it's actually not true. Okay. Because, even if you copy my songs, you need some bandwidth. Right? You need a server space. I mean, even in the extreme case of really, right? It's.
Yeah, but in that case, my production.
You need some time.
Okay, but in this case, it's a production cost. I mean, I need to make that. I need to.
No, you need to set up your server for Christ's sake. You need to set up your label, bingo bango label. Buy my, download my song, not EMI songs. I mean, come on, we are conversing, it doesn't matter, right? The point is that even in the limit case, it's a spitefulness. Okay, so that's one argument one wants to think about. Okay? Now, why is this useful pedagogically? It's useful to show that the argument, first of all, exactly like the initial argument, no increasing return, no growth, was nonsense. The argument that says no monopoly power, no innovation is also nonsense. In the increasing return case, the mistake, the missing point was, well, look, if you want to get persistent growth out of a constant technology, the only way you can do it is by having production function that are asymptotically linear, because you need to bound the average productivity, unless you make the crazy assumption that average productivity become infinite. But at that point, you're back in the von Neumann classical model, and you have added nothing to your explanation of reality. Here, what's the hidden assumption? Unbounded capacity. People don't go here because this is the outcome of Bertrand, right? If they had bounded capacity and they could play some form of Carnot monopoly, sorry, Carnot duopoly or oligopoly with many, then probably there would be some profits for the innovator and some other profits for the imitator, and this would be the equilibrium, right? And it would be a lot more reasonable, right? It would be a kind of Carnot or extended Carnot with a guy moving first and other people coming, facing some cost to imitate, and then getting market shares, right? With a first mover and followers.